Hi, I'm Somayeh Hussaini. I'll be talking about our ICRA 2022 paper on spiking neural networks for visual place recognition via weighted neuronal assignments. This is joint work with Michael Milford and Tobias Fischer within the KET Center for Robotics. The motivation behind our work is nature. We would like to mimic the useful aspects of animal navigation, including modeling how their brains work. Compared to deep neural networks, DNNs, that use continuous activation values, we use spiking neural networks, SNNs, that transmit information via binary spikes. While DNNs are the state of the art in a wide range of tasks, they are power hungry, making them difficult to deploy on compact robotic systems. SNNs instead are often much more power efficient and have low latencies, making them attractive for robotics. One potential area for SNN development is template matching tasks, such as visual place recognition, the task of identifying whether a place has been already seen, given an image of the place and prior knowledge of previously visited places. Despite the challenges, including changes in appearance and perceptual aliasing, where two different places look similar, VPR is used in many downstream tasks, including localization and SLAM. Our goal is to develop a high-performance spike neural network for the visual place recognition task via a well-weighted neuronal assignment scheme. We adapted an SNN model that was originally developed for digit recognition. The model contains 3 layers: input neurons, excitatory neurons, and inhibitory neurons. While DNNs use activation functions in SNNs, we can model neuronal dynamics of spiking neurons based on their internal voltage. We use the unsupervised spike time dependent plasticity (STDP) learning mechanism to enable the excitatory neurons to respond to different places. We convert images to spikes by setting the mean firing rate of an input neuron to the intensity of its corresponding pixel. Each input neuron is connected to all excitatory neurons. The connection between the excitatory and inhibitory neurons acts like a winner-takes-all system to limit the number of neurons that fire spikes in response to a place. The output of the network is the number of spikes of excitatory neurons. The highest average response of neurons to a label was used in the digit recognition task to decode the best matching template, which we named standard assignments. This was feasible as each neuron unambiguously learned 1 of the 10 digits. In our VPR task, we consider each image as a different place, resulting in a much larger number of classes. We observed that this resulted in a significant number of neurons responding to multiple places during training. To mitigate this, we introduce our well-weighted assignment schemes to consider neurons with ambiguous responses by appropriately scaling their responses. We tested our model on multiple trials of VPR datasets, including Nordland and Oxford RobotCar. Our weighted assignments in red outperforms the standard assignments in blue, and the performance of our method is comparable to conventional models that are shown in gray, namely NetVLAD and the sum of absolute differences, SAD. This video shows the qualitative performance of our model on a trial of Nordland. Given a query summer image, our model can find the corresponding matching spring image. Thank you for listening. Feel free to get in touch and please try our code.